Hello, am I audible?
Yeah, you are.
Yeah, hi. Welcome everybody. Uh, Here we are ready to start. And I would request you all to please, if you have any queries, then please go ahead. And so if you have gone through our Slack channel, then there are some queries. You can address those queries. Better if those participants are there, you can ask, then it will be a better. Hi, Sujit.
Okay, so now I'll start with today's lecture. Actually, I'm just setting up my iPad for session. So we will be doing today some sort of classification problem. And right, so let's go ahead with, I think I'll start. With the session, right? Okay. So firstly, I'll tell you something related to classification and regression and other stuff, and then we will be going ahead with the module that you have received today. Oopsies.
Sujit, when you are covering the maths portion, then it will be better to explain, elaborate it, because many students are not from the maths background. So they are feeling
If they
some
are
difficult.
not from the maths background, then it will be very difficult to explain them, no? Because yesterday's, like I think the last lecture, I asked on the chat, and many students already knew eigenvalue and eigenvectors, but still I went down to the basic of matrix multiplication. Now, do you want me to teach matrix multiplication?
No, 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 not specifically that thing, but like eigenvalue, eigenvector, SVD kind of thing. Like SVD already includes a lot of like eigenvalue, vector, these things. These
Single,
all will
yeah,
comes under.
single vector. Yeah, so I told them how to calculate the eigenvalues and other stuff, eigenvectors in the formula. Obviously, if you want it, I can put another lecture on that. But since only I think I saw that voting on Slack, and out of 188, only 12 of them said this thing.
It will be better like
So
for today we can circulate some videos so that they can have a better understanding
yeah,
of these mathematical things.
okay,
And
yeah, I can do that. I just circulate some of the videos or some of the blogs. However, I did give them a blog. I don't know if they studied it. If I clearly remember, for PCA, I gave them Sebastian Raschka, and that guy has implemented every PCA step, and we also did the PCA step. So if they do not understand the step or something, I need to be very clear. Or they just want to learn how to calculate the eigenvalue or eigenvalue matrices or something like that, eigenvectors, how to find out the values for that. Then I'll have to again do that. But you can understand there will be so many things. It will start with the linear algebra, probability, statistics, and keep on going. I will have to cover the sixth from class 6 to till now all the syllabus mathematics to come to this stage. So I will give you some of the links to read ahead. And if you have a problem in mathematics and still you can't derive it on your own, you are very welcome to ping me. I can understand you might say that I do not reply on Slacks because I rely on my TAs that they are doing so, and I have been looking over it that they are actually actively replying to you. But still, you feel that you want a video call and then do the consulting. Sure, you can go ahead with that. You can request a new one. I'll just cover those things in the mathematics for derivation. But there are going to be many things like we'll be doing different deep learning techniques and other stuff. And then you will ask me about partial derivative or something. It will be very difficult for me to explain every single concept there.
No,
So
of course.
the module that got, yeah. So the aim for this whole lecture series was to get you equipped with machine learning and deep learning models so that you can put a training on any existing data set using existing algorithms and modules. If you want to do the engineering with the module or change any specific algorithm, then that requires research, and that is should be your part. I can't do the spoon feeding, no, on those terms. But yeah, I'll try to do as much as I can. If it requires, then I'll tell you. I will let you. Uh, you can ping me anytime for this thing. For your mathematics. Generally, I thought for the explaining maths part or something, I do that in my free time. So my free time is generally in my night, so it will be early morning yours. So let's say that you're 4 o'clock in the morning to get up and study mathematics. That would be good. Okay,
So
so let's go ahead with, yeah,
better to first send them the video lectures of some mathematical topics.
yeah, yeah.
Even then they can,
Sure,
if
sure,
they
I'll do
cannot
that.
get, then we can think of having a separate lecture for mathematical topics, because of course
Yeah,
this is not a
sure,
absolute
sure,
part of
I'll do
ML,
that.
but without knowing how they can apply
Yeah.
it.
Yeah, yeah, definitely. So I'm like that. No, in the algorithms. So I am making very much sure of this thing that when I'm teaching the algorithms, they are looking at it stepwise. For example, even PCA, I could have done it like the other tutorials or other lectures. Like I can just say that okay, import PCA, and this PCA is equal to this thing, and your model is done. But yeah, we did calculate it stepwise. Firstly, I told you all the steps of the PCA calculation, and then you did it stepwise using program, and then I told you how to calculate the liability. But I cannot, I'm afraid I cannot do it with every single algorithm. So I'm doing it with you so that you can adopt it yourself to the other algorithms as well. We will do that the same thing with for KNN today as well. Okay. So let's go ahead with quickly. I think there were a few questions here with other students were asking the other day. Today it seems like there are very less participants, and then they will come up later by the problems and other stuff. Only 35 are here. So let's quickly go ahead with some of the basic terminologies that you might be hearing over the time. That is classification and regression, right? So what specifically is so classification is anything that you have let's say that you have these data points of class X, and then you have this data point of class O, and I give you a sample point this. I want you to classify this point, arbitrary point, that it belongs to which class, right? So the question now, what I will ask is, tell me that this is which class, right? So one approach that you can always see that I can draw a linear separable line here, and I can see that okay, it is a line which is distributing these two classes, and it is falling on this side of the line, so it will be belonging to this class. So generally classification will reach to the problem where you have the labels for different classes. So when you have the labels for the different classes, let's say that you see a picture of a cat and it is labeled as cat, then mouse, and it is labeled as mouse. So they will be called as supervised learning. And if you don't have the labels, you can say that it is unsupervised. Okay. Now you saw this thing when it was so when you have classes, let's say 1 0 or anything that is going to ask you a question that given these features f1, f2, f3 or f4, you have to tell that one specific data or the data point belongs to which specific class, then it will be a simple classification problem in very layman terms. Now we have to now the other thing that we also look at is regression, right? So regression is something that you have to predict along with it. Let's say we have a time series data of stock, okay? So this is the stock time series data where these are the time period and this is the price of any specific company, right? So with so now I want you to predict. Uh, so let me just delete some part of it. So let's say that you had this data set till 2020, and then I want you to predict that what will be the values for these company stocks in 2021 overall time period divided by the months. So then you will predict the prices based on the data that is present in the past, that what will be the corresponding values. So here we are using regression. So regression, generally examples that you will see online will be the problems where we have this thing uh, to predict the prices, house prices or something like that. Okay, so you have to predict house prices, given house prices of say 10 years. So based on the features present, you have to depict that what will be the house prices in the future. Okay, so this is generally what we call as regression.
Sir, are regression and estimation
Now,
same?
estimation can be anything, no? Estimation is so. For example, let's say that if estimation, it can be a bit variable in the term, like it's a vague term. So yeah, you can say it's an estimation of a price or a variable in a specific time period. Okay, or something. So we are calculating the possible values which can be, and then it will be obviously not the actual value. So there will be some error. So we will use different metrics for that. So then how so classification algorithm, so there are different classification algorithm which depicts what are the different values and which classes they belong to. So we will be going KNN today, and then I'll tell you in the meantime as well. So for example, for any training data, you have three. Basically we divide the data into three parts for any data classification or regression. One is training data, then one is validation data, one is test data. Many times you will see the validation and test can be used as each other, but it will be different from the training data. So let's say that you had 100 sample sets, okay, of 100 sample sets. So let's say that you have very clear in the terms, like you had 100 oranges and 100 apples. Okay, so you have 100 oranges and 100 apples. Now you need to distinguish, given a new object which is of the shape round and color red, you have to determine where it belongs. So let's say that the total number of samples you will have now is 200, since you have 100 apples and 100 oranges. So now 200 samples you have. So what you will generally do in order to, let's say, to train or test your model, you will divide this whole data set into a specific contribution X, Y, and Z. So let's say that you have 100 oranges. So I will divide all of them equally in 10 folds, right? So in every fold, I get how many data points? So in every fold, I will have 20 data points. Sorry, 20 samples, right? So now what will I do is I want to perform a 10-fold cross-validation. So I will use 9-fold to train my data and 1-fold to test my data. So now I will be training it on 180 samples and testing it on 20 samples. Now since it is 10-fold, we will be doing this 10 times. So I will train my model 10 times. So T1 will have, from let's say that you have data sets of 1 till 180, right? And then you tested it on 180 to 200. Now T2 will have similarly, let's say 20 to 200, let's say this one. And then test will have, let's say 1 to 20. And similarly, you will do all the permutation and combination to make the different folds. So you have 10 folds. So every time one will become 1, 2, 3, 4, 5, 6. So every time you will choose all other folds and just take one fold out of it to do the testing. So by this method, you will be getting at the end 10 different models. So models, what we are calling here is trained models. Okay. So 10 different trained models, and you will be able to see the accuracies on those models individually. Okay, so now it is very important that why cross validation is important here. The cross validation is important to generally we use it to train different models so that we can guess the hyperparameters, that which hyperparameter is best suitable are the best model as well. Okay, so this is generally the splitting of the train and test data. So you have train and the test. Validation, sometimes we use that validation data to check the training progress. That if validation, so every time a model is getting trained, you will have a validation corresponding to it to show that, okay, what is the loss, or in other terms, what is the error that you are getting, so that you can easily look at this thing and tell that your sorry tell that your model is performing good or not. Now I on the other day I covered the concept of underfitting and overfitting. uh, so on the other day I did something on underfitting and overfitting concept. So let's just give a very quick example of that thing again. So let's say that you have this data points. Okay, so if you, and this is the way your model is trying to train. Since it is trying to gather every single point here, it will be overfitting, right? So what will happen with this data set actually is that when you try to give a new data set, so new data point, you will not be able to actually accurately depict that it will fit on the line or not, because it has actually memorized the data distribution which it should not have, and now the new data set, it will be very difficult for it to move towards that which class it belongs to, because this is not a specific curve that we do. So any combination that we do is any combination that we do generally is to depict a curve or a line, right? A curve or a line or a plane that will separate my two data points in a 3D space or 2D space, and that will be very difficult for us to do. So any combination that we do is and then you have this one. So let's say that this thing, this is your training loss. So let's give it loss, and this is epochs. Epochs, let it be the iterations, like number of times you're running the model. So if this is your training and this is your test, so the perfect timing to stop any model from training would be this area where it is almost close to each other. If you stop it beforehand, it will be underfit. If you are now going it there when the losses shoot up after the coming down, it is overfit. So when we will be doing deep learning concepts, okay. So now we have, so there can be many things that we have to go ahead with the combinations in terms of overfitting and underfitting, as well as when it can be. So like when you train over your model way too much, that can be one possibility of overfitting for a very long period of time. Underfitting can be when you don't train it enough. Then your hyperparameters play a very important role as well. If you have a very less data points to train on your model, then also if you consider, and it's not evenly balanced. So there are a few things that are very important for your model training, that the classes in your, so the sample point of specific classes should be balanced. So if let's say that you have 100 samples of apples to train on and just 30 samples of oranges, then the model will not be able to learn the feature about the oranges very clearly as it will do for the apple. So it will be automatically biased towards the apple. So it is very important that we have the similar distribution on this one, right? So similarly, we'll cover, so today we are going to cover the concept of KNN. So KNN is like, you might find it like this, like you have, let's say I ask you to write a program or something, not even a program, let's take very simple, that you have again this data point, and then you have this data point, these data points, sorry. And then I ask you to classify this one. So how are you going to do that? So using k nearest, KNN stands for k nearest neighbor. You try to find out the nearest neighbor by taking a point and calculating its distance from each other. Since we are talking of the Cartesian geometry, we'll be calculating out Euclidean distances, and then we will sort them in order of the nearest to farthest, and then we'll see where it lies up. So we'll start with this today, and then we'll continue to the next class as well, where we'll be doing some lasso and ridge, as well as L1, L2 normal, L1, L2 norms. Okay, so I'll just quickly go ahead now with this thing. So if you have access to the today's notebook from the Slack, you will be able to do it. So this is the notebook that you have to use today. So we are using pandas. So we are using pandas, uh, and then you have numpy as well as matplotlib ALT. You have to load the dataset. I have dropped the dataset already in the Slack, so you will be able to use the dataset. So you see the dataset contains the information about the pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and outcome, right? So just open this dataset, and then we will be able to go ahead. I'll give a minute to everyone to open up their dataset and load this specific part. Okay, so now you all have done it, or I hope so. So you can So now, so we have loaded the data. So you have glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, age, and outcome. So one outcome is like one is your one class, zero is the another class.
Sujit, please give 1 more minute.
Okay. When everybody is done, please show a thumbs up.
Guys, if you have any problem, you can stop us. Okay, Sujit, let's move ahead.
Right. So here we have uh, yeah. So one thing, wait a second. Right. So we have loaded this whole data set, and then we have all these parameters that we have seen. So when you click on data.info that we have already seen, when you try to get the data.info, you will be able to get the columns name, that is pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age, the outcome. So there are total number of uh, outcome you have is 768. So 768 values are here. So the outcome is actually representing the diabetic or non-diabetic. So you have to segregate them into diabetic or non-diabetic. So just describe again. We have all seen these all functions. So describe will show you the different description. And here we are going to replace the 0 and 1 with diabetic and non-diabetic here. So now when you will have when you will look at the outcome in data.info, you will be able to see that now that 10 is showing you actually diabetic and non-diabetic. Okay, sorry, non-diabetic and diabetic respectively. So then can minimum values of below listed columns be zero? So we have to check specifically that if these columns can ever be zero or not. So you have the so for this, actually, we try to use is null, right? So we try to see that if there are any null values. We have seen this in the previous classes itself. So we just copy the data from the DF, and then we have the DF. So these are the DF, so glucose, blood pressure, skin thickness, insulin, and BMI. So we have these values cannot be zero, which is glucose, blood pressure, and skin thickness. So we are replacing the zero with none, since after counting them would be easier, and zeros need to be replaced with suitable values, right? So we are replacing the zero with none values here. So now if I do that, so you see here, so pregnancies, you have zero glucose, 5 blood pressure, skin thickness, insulin, BMI, and diabetes, peripheral function, age, and outcome. So now we can fill the null values either with a mean or a variation, or sorry, or a median. So it is general technique that you will see. So I'm just telling you one of the methods. You can either replace the zero with a mean or a median, or you can also do a moving average if it is something related to time series. Okay. So when here again, so what I'm doing is I'm trying to use in the data frame. I'm using the column glucose, and I'm filling the NAN values with in the data frame glucose with the mean of data frame glucose column. Okay, so and in place is true to keep the same order. Okay, similarly, in the data frame of blood, in the column of blood pressure, I'm filling the Na with the blood pressure dot mean. Similarly, for skin thickness dot median. So we are using the median for skin thickness, insulin. Then you have again median for insulin, as well as for BMI, we are using the median, right? And now we just go. Like I have very specifically told you that it can be different values as well, different method to fill them. I'm just telling you one of the methodology which you can use in generally to get some reasonable accuracy or train your model. Right now, we see that to find out the values that how many are null now. So now when we run it, we see that there are none of the values have null values, right? So previously we had these many values null. So now the outcome of the value count. So we are looking at the value counts and then trying to plot a bar here. So looking at how many values are for non-diabetic and how many are for the diabetic. So you see there is an imbalance here. So diabetic and non-diabetic. So they are not completely equal, right? So the number of non-diabetic almost twice the number of diabetics, right? So now we are selecting the columns which is 0 to 8. And now you are doing the pre-processing, same that we did in the last class. We are using the min-max scalar and then using the column to fit transform on the column. And then here we are doing to the head. Okay. So we now have transformed the data. Now, as I have taught you right now about the train and test split. So here we are using a train test split function where you are giving a data, you are using the split, you can use train data, test data, okay? And then you're doing a split here. Now, this all thing can also be done by a library using sklearn, okay? So in the, like, I'm giving you the, for a mathematical understanding how all these things perform. Like you can do that in a straight line using sklearn dot sklearn dot preprocessing dot test train test split, and then you will be able to call them and just give the data along with the split percentage that you want, and then your test data will be outcome. Sorry, train and test, train data, train labels, test data, test label will be out. Okay. So now if we look at it, so we are using a definition here, train test split. So data split, train data, test data. So we're going to tell the splitting percentage here. So X in the range, length of the data, it will go up to the till your data is. Random.random, it will split the data and then append it into the train data. Okay, and then similarly, otherwise it will append them in the test data. To visualize this very similarly, I can tell you, like you can imagine this program who are not from the programming background, just for your visualization, you can imagine you have 100 rows in an Excel sheet, right? And I asked you to assign one or two randomly to 70 variables, and uh, randomly assigned to 70 and 30. So like 70 rows randomly assigned one, and other than will be 30. So I'm just selecting the one in the train data, and the other one which are left are in the test data. If my training and test ratio is 70 to 30. So then we are calling here train test split, data frame split, train data and test data. Now my split is 0.7, which represents 70%, right? So it will be train data will be 30, sorry, test data will be 30% and train data will be 70%. Sorry, I did not define it. Okay, so now I want to see the size of the training data and the size of the test data. Okay, so training data and test data. Somebody asked what is random.random. So we imported random to assign a random variable. So it will generate a random number based on the Gaussian noise. I think it uses the Gaussian noise to generate. Or it, like you can, in an easy terms, you can say the random variable. So now we have the training data and then we have the test data. So we see that now the number of train data is 542 and 226 is the number of test data we have. In total, we had 768, correct? Yeah. So 768 data we had, right? So this is the train data and test data. Now, we mixed for the both the classes. So it contains the information about both the classes here. So now we have to calculate. So we are going through the step by step for the Euclidean distance, right? So now we have split the data set into train and test. Now we are going for the calculating the Euclidean distance, as I have shown you on the sheet itself, that you will calculate the Euclidean distance between two sample points. Now the formula for Euclidean distance, I hope everybody knows. If you don't remember it, it's like x1 minus x2 whole square plus y1 minus y2 whole square and complete over root. Okay, so we are going to calculate the Euclidean distance of xi length, then d is 0, so the initial distance described here is 0. I in the range of length, so the length is the length of the data set that you provide come down. So I in the range of length d plus equal to, so we are trying to add here to the value d, which is the float xi. Obviously it can be decimal values as well, and float xi. So they are two different value rows that you have picked up, right? So float xi comma 2. So you are going to this one minus this one whole square, okay, and then you are taking the square root of d. Okay, so this is what you are returning. Just hold on. I will also show you the step-by-step variable calculation in Spider itself. So here again we define a get neighbor function which will calculate the neighbors, right? So k neighbors having the closest Euclidean distance to test data. Okay. So now, so you have train data, test data, and k. So distance is empty right now. Length we are say whatever the test data has length. Now x in the range of length of train data, it will calculate the distance by this formula, Euclidean distance of test data to the train data. So every time this line will run, it will go into this function to calculate Euclidean distance, and then distance will be added. So you will have distance output here because it is returning a single variable, which is math dot square root d. So you can just use square. So this is a function to use to calculate square root in Python. So you are using math dot square root d. It will return this. For example, if the d was 4, so the output of this whole definition will be 2. So in distance, you will have the value 2 here, and then you will append that distance because it is a list, and we remember from the first class to add the distance to the list. So here the distance I have appended to. Now we will sort all the distances, right? In the decreasing order. So we will calculate the accuracy, and then here you prediction will be right. So your accuracy will be the classes that it classified correctly divided by total number of classes present, right? So it will be doing this thing. So test
Yeah.
data predictions, and then correct plus is equal to 1, and then
Sujit, Sujit,
speak.
sorry to interrupt you. Am I audible?
Go ahead.
Is it possible to run an individual line and then show the result, because it will be better visualization of the each and every line.
Yeah. I know that. I know that. I have just said it, no, that I'll run it in Spider and show you every single line output as well. So you can do that at home to understand it better.
Okay,
So I'm
okay,
just reading the definition first so that I'll not read it again. I'll just show you how it is going, right? So
okay.
you will calculate the accuracy, and then here your predictions will be made. So for everything that you're going here, you will be predicted diabetic or non-diabetic. And then you will calculate the accuracy. To get accuracy, test data, prediction, and accuracy will be this much. So this is how we calculated using KNN, step by step, by calculating simple, by using simple mathematics. And other thing is you can do it in 2 lines maximum. Is just use here sklearn dot pre-processing import standard scaler. So you're just using scaling here, not doing nothing. Same thing. You're using sklearn dot model selection and using train test split. So the way we did train test split, you're not doing anything. You're just importing this library, and you're getting x train, x test, y train, y test. So x train is your training data set, and y train is the label for the training data set. Similarly, x test is your test data set, and y test is the label for the test data set. And it got split into 1 ratio in x comma y random state given, and then 1:3. Okay, and then print. Then you have the length of x train, x test, y train, y test. So whatever I said, so x train training data set with the training level same size. Similarly, y train and y test. Okay. So now here you calculate. So now what we are using is k-neighbor classifier. So you just use one line here, which is k-neighbor classifier sklearn.neighbors, and then you're just going to do here is train test code and the range of KNN is equal to k neighbors classifier for I, KNN dot fit x train, y train, and then train test score append, KNN score x train, y train, and predict. This is our accuracy. So this is very much straightforward to do all the things that we did through the definition. Now let's
Hello.
still go through the mathematics in the definition.
Hello. Can you hear me?
Yes.
What do you mean when you say neighbors? Because you've been using it a lot, right? So what is the exactly meaning? And so yeah.
So neighbors are like the same, the data point of samples which are nearest to each other. So let's imagine that if you have some things of very same classes, right? So of same class, so they will, according to the very perfect hypothesis of 100% classification, you can say that they all of the same class with the same features and they will stick together. So for one sample point, the other thing can be treated as neighbor. Okay. So here we get all this classification and then we got the line plot. So just forget about this plot first and we'll go to the spider and see how it is done. Right. I cannot zoom it. That's why I showed you that thing. No, I can zoom only this thing, but I can't zoom the variable explorer, I think so. Yep. Okay. So we'll have right. So this is the same program that we just wrote. Okay, in the same format. So let's quickly. So we all know this definition that we have explained, but we want to see the implementation. So I just use it where I'm calling all these functions. Okay. 1 second. Sorry. Yeah. So where I'm calling these functions. So I'm calling these functions here to get the neighbors and result in the prediction in the test data. So I'll run it completely till here. Okay, so now I have the data set here. You can see in the variable explorer. Can you guys all see my screen of spider in the variable explorer and other stuff?
Yes.
Okay. So we can see the variable explorer here, and you can see the data set we have is 768 by 9. So 9 are the different features that we were having. Then you have the data frame here, and k is equal to 3. I'm extremely sorry, I don't think I can make it bigger. So if anybody else has experience with it, they can let me know that if I can zoom it or something. Let's see one thing. Right. Now can you see it? I think so. Use the full
Yes, much
magnification.
better.
Yeah. So I use the full magnification. So here we have the data frame, and the so data frame located at 768 by 9, 768 by 9, and then you have here the K is defined here as 1. Predictions, so it is empty. Split, as we have seen in the previous program, the split that we wanted was of 70-30. So we have 0.7. Then the test data and the train data. So now the test data will be a list series that with all the variables, and the test data is 235. So let's try to open one of them and see what the output looks like.
What is this 3 in front of K?
Where K is equal to 1, no? 3 where?
In next column, it is written 3 as well.
Or the value of K is 3. So this all thing represents the value.
Okay.
Since you started, and okay, so if you want to see that, so since you started with, so K is equal to 3, you selected here. Okay. Now, once we open the train data set, you see you have a series here. Okay. And you will have all the samples here. Okay. 532 samples. Let's open one random sample and see what the values are here. So we will have pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetic prediction, age, and outcome. Right? Outcome is 0, obviously. So it is the Y label. So we are trying to get the index of here. So we are having now 532 series of all these features. So this is in the train data. Now similarly in the test data set, you will have the 235 one. Okay. Now let's come back to here. So we are looking it in the, this program will go up to the loop that we are able to see here is till the length of the test data, and then we are going to calculate the neighbors. So let's go to the next line, and we are here. So now the value of X you can see here is 1, and the test data, right? So the length of the test data is 235. So it is going to calculate the neighbors. So neighbors is called in the function get neighbors. So it should, where it should go? It should go into the definition of get neighbors here. So definition is derived here. Let's see that if it goes into this one or not. So we got to the get neighbors. Now we already, when we were calling the get neighbors, we called up the train data as well as test data, and specifically X, which is corresponding to the data. So test data of 0. Okay, right. So we have test data 0. So we'll select the, so if you just try to debug it right here. So in the, if you look at my console here, so if you just write, again, you would not be able to see it. So I'm using it. So test data, and then we are trying to see in 0. Okay, so here are the values that we got. Okay, so it calls up to that, and then now it has gone to the function here. So train data, you have the training data anyway, which is here, and then the test data is here, and the K is defined. Okay, so now the distances are empty, and the length is defined. So let's go to single one by one and try to look at all the variable change. So distance, so now once we go here, so you see distances has been added here and it is empty. Now we will define the length. So length is equal to 8. Okay. Now here we have X in the range of length of train data. We're trying to go for that, and X will start with 0 again. So you will have X is equal to 0 here. And then we'll calculate the distance. So distance is equal to Euclidean distance of test data, train data of X and length, right? So if I go into this function, we will reach here. We go to the Euclidean distance, and then we calculate 0, 0 for I in the range of length, and then we cut. So I'll just go step by step. So we have D here defined as 0 here. You can see it in the variable explorer. Right. Uh, uh, so D is 0 here. Okay. So now when I go here, holy shit. So we go to the next line and we have for I in the range of the length, and now D, it will give you some value, which will be the for float of xi, comma 1. So let's quickly have a look at it, that if this is the value and x, we know that x is equal to, x is a series of 9 that we are able to see here. So this is the series of 9. So xi will be the first value, right? So I is equal to 0. So if I just write here xi will get the value of 0.35. So we have this value, and then you have xi comma I. So you will have xi as well. Xi is also series of 9. So you will go for xi I, and it will also be a value. So it will do what? This minus this, and then square of this one. Okay, and then math dot square root. So then you calculate the Euclidean distance. So let's say the d value should change. Now it, okay. So now you see the d has been calculated. Okay. Similarly, you will calculate it again, and d value has been updated. So right, now we have 533 values here in the series. Now, so similarly, when you will go to this one. So now with other data points, and then what we are doing here is we are sorting the distances and then taking up the neighbors. So I just move ahead and go here. So we have, now we'll get the results. So result is here. So we are getting, trying to see that the result is the get response of the predicted result will be printed. Okay. So predicted is this, actual is this. So there is a, this is a wrong prediction. So it will keep on happening, and you'll see the append going on. Okay. So by this method, you will be able to train well in the spider. I would encourage you to do that step by step. Just copy this every cell into your spider as it is, and use the same debugger technique that I used. So just to repeat that, you just need to press on any of this side, double click, and it will be attached a debugger here. Okay, of red color or something. I would encourage you to start a changer or something, and you will run this button, click on this button to run the debugger. You will come to this line. This is for moving to the next line, right? This is to go into the function. So when we have a specific function that we have defined, let's say train test fit, Euclidean distance, and other stuff, we'll be going through that function. To go into that function, you use this button. Sorry. So similarly, we have this random train test split. So we did all the calculation. So we go for this, we have this, then we calculate the Euclidean distance, we run this definition as well. We get the response in terms of vote. We try to calculate the accuracy here, and then we print the predictions here. So in some cases, you see it is non-diabetic and predicted as diabetic. Actual is diabetic. So it is giving you the actual, and so in one of the cases you see it's non-diabetic and actual is also non-diabetic. Non-diabetic, actual is also non-diabetic. So there are some true predictions and some are so let's say that how much accuracy we got. So we got an scalar. It is simple one line. So simple, just using the library and not using the mathematics behind it. So mathematics is very simple. You calculate the Euclidean distance between the points and then you sort them in the order. And I made a mistake. And you have this thing. And you split it and then you test the length of the training data and test data. And here you get the prediction, the KNN classifier. Right? So now we try to plot the training score marker and along with the test score. You'll get this one. And then you can also see the KNN with the diabetes data as this one. Okay, so this is just another plotting for decision regions, how it was calculated for a specific decision and specifically another decisions. Okay, so there are other things that I had to cover today, but I'll leave it to this point because I want you to get familiar with these things first, which is the running of the program, and run it first, and then we can cover the confusion matrix and other stuff in the next class, in precision score, F1 score, and other stuff. So we have seen the accuracy here today. So accuracy you can just say that it's true positive. So just forget about anything. So it's like correctly classified classes. You can just say that. Okay. So accuracy is your correctly classified classes. How many out of how many it did it. So it's a simple probability. Okay. So I'll stop sharing here, and I would encourage you to please go ahead and uh, record the lecture. It's already. Sorry, I did not see the chat before, and then so just please go ahead and use the same program that we have used in the terms of diabetic, and please use it using Spider or PyCharm, whichever you're familiar with, in order to do the debugging. I've told you how to do the debugging with Spider and see how the values are getting changed and added and other stuff. And then I would request everyone to send me a screenshot of the variables that you are getting on this. If you are successful, please do share the screenshot in the terms that you have been successfully understood and and if you're not, I have. Okay.
Sujit, yeah, Sujit,
Go ahead.
I would like to also say the participant like you can shortlist your problems from whatever have been covered so far, and we can have a session for uh, doubt clarification about all the topics, irrespective of which lectures you are asking from. So that till now, whatever we have covered, that will be uh, refreshed again, because we are now moving into machine learning. I think really, isn't it?
Yeah. Yeah. So now we'll be doing all the training of the models of different model and other stuff. It's always so. I'm not going to repeat any of the concepts that I've already covered in the past until that I feel it to be important and very much it can be every implemented to every single class out there as well. Right. So it can be implemented to every other data out there. Sorry.
Yes, yes, that's why I'm
Possible with
asking.
this.
Students can shortlist and then TAs can give them some brief idea. Even then, if they have some problem, then for those shortlisted questions, if they are considerable, then we can have better explanation over there.
Yeah, yeah, definitely, definitely. Absolutely. If you have any specific problem or something, just please ping anything, because after this one, we'll just discussing different models and their implementation.
Yes. So, okay,
In
guys,
some of the
thank you.
model, we will discuss some of the concept, but in some of the model that we will not be going into the deep of the mathematics, because this is considered basic. If you want to consider the mathematics, maybe you can Okay. I did not get the question from the competition. Could you please elaborate? So competition problem was very simple. It is to classify I think the problem statement was very much easier, isn't it? Let's see. So your developed project must demonstrate the learning to date and knowledge of machine learning data model, including the. So this is the data set that you're using. So this is AIBL data set. So they were categorized in three different clinical diagnostic results: healthy control, mild cognitive impairment, and Alzheimer disease. And then you will have two categories: and ED as one class, which will represent non-HC, and HC will be HC only, healthy control. So let's say that healthy control represents 0, and MCI and Alzheimer disease represent 1. So you have to classify them into 1 or 0. Is it is it fine now? Everybody, is it fine? The competition question now.
Yeah, people are saying yes. Uh, Hi, Rishikesh. Uh, you are asking something from PGNC.
Another
So,
challenge, which will be the most important to analyze. So you at the end, wait, just don't stop in between. So as soon as you progress ahead, and you will be getting to the end when we learn about the other models and features and other stuff, I'll be giving you some difficult problem. Maybe I'll give you a problem of a signal to classify the signal as specific values. Once I cover these two aspects, which is now you're doing a raw data and the signal, I think that you would be very much easy to incorporate the machine learning models on any other data set, whether it be image, signals, raw data, Excel sheets, data processing, or anything else as well out there. Easy to implement. Right. So that would be it from my side, Prayag. Thank you very much. I'm running late for another meeting.
yeah, I'm also running late. So, sorry, Rishikesh. We have a separate channel for surveys and all. So, Rishikesh, please make your comment in that, and then I will check comments from there, and then I will raise that comments in the next session. Okay, guys, we are stopping the meeting here. Thank you all for joining us. Have a good night.